All right, part two, section 5.3. We're going to look at something called reference angles. All right, so your book talks about the reference angle for an angle theta is the acute angle theta prime formed by the terminal side of theta in the horizontal axis. Well, what does that mean? All right, let's look at an example. Let's suppose that we're looking at an angle that maybe is in quadrant 2 with the terminal side, or the terminal side of an angle is in quadrant 2. So we have an angle in standard position. Let me redo that. I have an angle in standard position here. And we'll call that angle theta, okay, whatever that might be. And then what we're seeing is the reference angle is an angle that has the same terminal side here as your regular angle theta, but it's the acute angle made from that terminal side and the x-axis right there. And we call that angle theta prime. Okay, let's look at maybe an angle in quadrant 3. We're looking at an angle whose terminal side is in quadrant 3. We're looking at an angle that goes around like this. Okay, we'll go ahead and call that angle theta right there. Okay, and the reference angle is going to be the angle that's formed by the terminal side, the acute angle formed by the terminal side, or I could say the acute angle formed in between the terminal side of theta and the x-axis right here, okay? Terminal side of theta and the x-axis. And we call that theta prime. Now, what about an angle in quadrant number 4? Angle at quadrant number 4. I keep saying an angle in quadrant 4. What I mean is the terminal side of an angle lies in quadrant 4. Okay, suppose this is the angle theta. Now, what is the acute angle formed? What do I mean by acute, first of all? I mean it's less than 90 degrees, right? Between 0 and 90 degrees. What is the acute angle formed by the terminal side of theta and the x-axis? That would be this angle right here. We're going to call that theta prime as a reference angle. All right, now let's think about how we find this angle, this theta prime, this reference angle to help us out here, okay? All right, so let's go ahead and say, I'll tell you what, let's pick the green again. Let's say that we want to find theta prime for this example right here. How do we do so? Well, let's look at what we have. Let's look at it in radians first, okay? If I rotate 90 degrees, that's like rotating pi over 2 radians. If I rotate 180 degrees, that's like rotating pi radians. If I rotate through an angle of 270 degrees, that's like rotating 3 pi over 2 radians. And if I rotate all the way around 360 degrees, that's like an angle of 2 pi. All right, now let's look at how we're going to find theta prime here, okay? So we're going to say, if I want to calculate theta prime, the measure of my reference angle that is right here, what do? Well, here's one way I could think about this. I could think about it, okay? To find the measure of theta prime, I would say this is 180 degrees from here to here. But I could find this angle theta prime right here by saying start with the 180 and take off this much, and I'll be left with this amount, okay? So if I take off this much, that's taking off what? Theta, right? So what is it again? It's 180, but take off this amount, which is theta. So let's write that down. Theta prime in this case would be, actually I said 180. Go ahead and put that. Theta prime will be 180 degrees, but take off theta. Now think about it in radians, okay? And radians, what would we think of? We would think of going from here to here is pi radians. So now if I take off this amount, or theta, that gives me this theta prime. How do I find it again? I say, okay, pi radians here, take off theta. So pi minus theta. Now that's for quadrant, what? 2 reference angle. How about over on this second example with a, let's look at a radius first of all. Oh, wow. Okay, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. You need to be as comfortable with this as you are with degree measure, okay? All right, let's suppose I want to find the measure of theta prime. Let's actually sort out the radians this time, okay? Theta prime. Pick a different color here. How would I do so? Well, let's take a look at this picture that we have. Picture's worth 1,000 words, they say. Well, see why. All right, couldn't I say my reference angle is going around this much, but then take away all that. So in other words, this part where I said going around this much is going around what? An angle of theta, and then subtract this amount, which is what? Pi. So what do we have? Theta prime is equal to, or theta minus pi in radians. What would it be in degrees this time? Theta prime. It'd be theta minus what? 180 degrees. All right, go ahead and pause the video and try to do this one right here. Try to do it in radians and degrees. All right, so let's see. Theta prime in radians. Let's see what that would be. Okay, so if I go around that much, that's what? 2 pi radians, right? But what if I take away this amount? Then I'm left with this reference angle, right? So what is theta prime going to be in radians? It's going to be 2 pi radians, but take away what? Theta. How about degrees? Theta prime, the way we find that, it's going to be what? 360 degrees minus theta. All right, what if we do some examples with these? What if we have an example that reads, find a reference angle for the given angle. Find a reference angle for the given angle. For the given angle. For the, we're going to have 225 degrees. We're going to start out with. All right, so to work this problem, what do? I'll go ahead and draw a picture first. See what I'm working with here, okay? This is 90 degrees. This is 180 degrees. This is 270 degrees. So where does that put 225 degrees? That puts that somewhere between what? Somewhere between 180 and 270 degrees. So here's my angle, regular old theta. Terminal side of this angle is right here, okay? Now what is my reference angle associated with this? It would be the acute angle between the terminal side of theta and the x-axis. So it looks like that. We'll call that theta prime, okay? Now, if I start out with degrees, I want theta prime to be in degrees as well, okay? Now, how do I find that again? Instead of memorizing those formulas I just gave you, what I actually do is I just think about them each time. I say, okay, the way we would find that theta prime angle is we would say, okay, all this is theta, and then take away this part, and I'm left with this theta prime measure. So it'd be theta minus all this part, and what's all this part measure? 180 degrees. So what would theta prime be? Be theta minus 180 degrees. So theta prime is equal to, what was theta? 225 degrees minus 180 degrees. Well, what does that give me? 45 degrees. Or B. How about I'm given 3 pi over 4. Let's draw a picture, see what that looks like so we can find a reference angle here. Remember, this is pi over 2 radians, this is pi radians, this is 3 pi over 2 radians, and if I go all the way around, that's 2 pi radians, right? All right, so 3 pi over 4. What does that mean? That's really the same thing as 3/4 of a pi if we just bring the pi to the outside right there. Well, think about it for a second. If you go this much, that's pi, right? So wouldn't 3/4 of that or 75% of that be somewhere around this area right here? So the terminal side's going to lie in quadrant number 2. Don't worry about if you went quite enough, close enough to pi, or if you're supposed to be a little closer to pi over 2 or whatever. You're not drawing these things to scale. You're just using a visual so you can go ahead and figure out how to work the problem. All right, so what is this? This is 3 pi over 4, or 3/4 of a pi, depending on how you like to write it. Where is my reference angle here? My reference angle is right here between the x-axis and the terminal side. I'll call that theta prime. Now let's find a measure of theta prime here, okay? How can I find a measure of theta prime when I'm in quadrant 2? What I think of is if I rotate this much, I'm going to be at pi, right? But then I take away this amount, which is 3 pi over 4. So again, what was that? That was pi minus theta, which was 3 pi over 4. And what does that give me? What's 1 whole minus 3/4 of a pi? 1/4 of a pi, or I could say pi over 4. Same directions here. Let's call this C. Part C, we're going to be given 17 pi over 3. Oh, how dare you with an improper fraction. Guess what? We got to deal with these, right? We see them in real life. We got to deal with them. All right, so let's do like we did before. Let's figure out where it's going to be. Here's pi over 2. Here's pi radians. Here's 3 pi over 2. Here is 2 pi radians. Well, I don't know where in the world 17 pi over 3 goes. So let's go ahead and convert that to a mixed number. Man, it's been elementary school since I did this. How do I do this, Mr. Fontenot? Well, I'm glad you asked. Ask yourself, 3 right here times what up front will give me close to 17 without going over. 3 times what gets me close to 17 without going over? I'm going to say 5. So 5 would be my whole number portion. But 3 times 5 is 15. So take away 15 from the 17, and what do you get? 2. And keep your old denominator, which was 3. Be sure you put your pi on it, though. All right, now this right here, this 5 2/3 of a pi gives me a much better understanding of where I'm at. So I rotate 5 pi, then I rotate 2/3 more of a pi, okay? So if I rotate here all the way like that, that's 2 pi, right? So I went around 2 pi. I still need to go around at least 5 pi, right? So that's 2 pi. If I go around again, that's 2 more pi, or it puts me at 4 pi. Go around a little more. That's 5 pi. If I go around one more pi, now I need 2/3 of the way to this other pi over here. So 2/3 is about 66.7%. So somewhere around there, right? Put my terminal side there, fill that in. And we'll call all those loops theta, okay? Which was what? 5 2/3 of a pi. All right, so where does my reference angle appear? It appears right here, and we call that theta prime. Now, how could I find a measure of theta prime? Well, look at how much you went around here, okay? Went around right here, what? 2 pi, 4 pi, 5 pi. Then if you went all the way to right here, that would have been what? 6 pi, right? So 5 2/3 plus how much more will give me 6 pi? Well, I would say 1/3 more of a pi, or pi over 3. Now there's different ways to do that. That's perhaps the easiest way to do it. Another way you could do it is you could find the angle that's coterminal with this angle right here, and then do the subtraction. Doesn't really matter. It'll get you the same thing. So if you watch other videos, they might show the other way. That's fine as well.